So let's talk about the programming assignment first. I assume it was easy for everybody? Really? It was hard? Oh, the last part was the easiest one. And I even made it easier for you. I usually give a harder version of that. I gave you some things to make it easier for you. Okay, I told you to remind me to show you the hard way today, right? All right, good. All right, so let's look and see what the assignment was, and then we'll find out if I can solve it. And if I can't solve it, then I guess we're done for the day. All right. Let's see. Okay, you had to write multiple methods, right? So print vowels, print consonants, print digits. So first one, print vowels. This method should take a string as a parameter and print out all the vowels contained in that string, one character per line. And I gave you a hint last class, right? Something probably with the index of method. Let's see, is this it? All right, so we're supposed to have a method called print vowels, so it's going to be void. We need to have static because I told you for right now everything's static. Void print vowels. This guy's going to take a string as a parameter. Now, what I think you should do, this is what I suggested last time, is create a string that contains all the vowels. A, E, I, O, U, A, E, I, O, U. So that's all the vowels, right? All right, then we're going to have a loop. That goes through every character in our string. So this is our stock for loop that goes through every character in our string, and I probably shouldn't name that S because I'm taking in an S, so I'm just going to call that map. Actually, let's call that vowels. That's a good name for it. So this loop is going to start I off at 0, keep going as long as I is less than the length of our string. Add 1 to I each time. And then each time through, we're going to say if vowels dot index of s.char at I. So if the current character I'm looking at, when passed in the index of method of vowels, does not equal -1, that means it was in that string. So I'll say system.out.println s.char at I. So this is the current character, right? So that's the character we're looking for, or we're looking at. What I'm going to do is I'm going to use the index of method of vowels, passing it that char. And if it returns something other than -1, which means it was not found in there, okay, something other than -1, that means it's not a vowel. Oh, I'm sorry. If it returns a -1, it means it's not a vowel. If it returns something that's not a -1, that means it is a vowel because it was found somewhere in here. It was found either index 0, 1, 2, 3, 4, 5, 6, so on and so forth. So if this guy returns something other than -1, that means it is a vowel and therefore we should print it. All right? So we can call this guy, pass it hello, and this should print out what? The E and the O? So there's our E and our O. And we see it also works on uppercase E and the O. Okay, it works on uppercase because this vowel string, I put all the vowels in, upper and lowercase. All right? Does that make sense how that index of trick worked there? I'm just using it to search. And I'm taking advantage of that fact that index of returns a -1 if whatever you were looking for was not there. Okay? So if I'm looking within a string of vowels, And what I'm looking for is not there. That means it's not a vowel. But what I'm looking at is there. It is a vowel. Because this guy only contains vowels. Second one was what? Print consonants. I'm just going to copy this whole method. Spell it right? So we got to put in, go ahead.
Instead of writing a string, declaring the string in a separate way, we can write in the if statement. If instead of writing vowels, we can write the index beside the index value, right? A, E, I, O, U.
Well,
Instead of declaring separately.
oh, instead of declaring this, you want to say.
Yeah.
That. Yeah, that's fine. It's the same thing. Variables resolve to their value. Okay, so now print consonants, we need to have our collection of consonants here. Now it's important to recognize that the consonants are not things that are not vowels. So we can't say if it's equal to -1. If this guy is equal to -1, let me just steal this word so I don't have to type it again. So when looking for the character inside of consonants, if it says it's not there, that must mean it's a consonant because this guy only contains vowels. That won't work. There's plenty of characters that are not consonants that are also not vowels, like the number 1, like the question mark, like the exclamation point, things like that. All right, so we're going to have all of our consonants, our non-vowels. So what I'm going to do is just to make this easier. Did I show you the 2 uppercase method last time? Nope. Okay. I hit caps lock. Caps lock. All right. All right. So that's all the letters in the alphabet. Now I'm just going to go through and take out the like that. So exact same solution as we had before, except this time we are passing in a different string. Or we're looking at a different string. So we'll call driver.print consonants. Passing it HELLO, and I should just get HLL. Oh, thank you. The thing I was telling you before not to do. I forgot to switch it back. There we go. HLL. And we'll see that if I throw like a number 1 and a question mark and an @ symbol, we'll see we still only get the HLL. Those things are not consonants. They're non-vowels, but they're not consonants. Okay? Then the next one was print digits. This is the 0 through 9. So we'll steal this. steal this. You know, you don't have to rename this, but I will just for the sake of. All right, so there's print digits. And this guy should just print out a 1, the only digit that was in that string. All right, questions about any of those three? Now, if it were me writing this, I probably would have written a little helper method here. I would have said something like static void, see, print in set, and I would have this take in a string s and a string set. I would steal all that code and just do a search through set. So now I have a generic method that I can pass any string to, as well as a set of things that I want to search for. And this guy will generically go through every character in that string, checking to see if it's a member of this set. If it is, it'll print it. So now how I'd use this is down here, print vowels, I would just say driver.print in set s and vowels. For print digits, I could do the same thing, except instead of passing it vowels, I'd pass it digits. For print consonants, exact same thing, except instead of vowels, I'd pass it consonants. That makes sense? So I write this one method that captures the pattern that was in all three of those other methods. Okay, what am I doing? I'm going through every character of this string, and I'm checking that each character against this set of characters. Okay? And if it's in there, I'm going to print it out. Make sense? So this is a generic method that will now print anything, go through every character in S and print that character if it's in this set. And now I can utilize that tool in all of these. All right, questions about that? So that would probably be a more object-oriented way of writing this. Well, object-oriented is not the right term. This would be a better practice of writing this solution would be this way, so that we're not repeating this code over and over and over again. Because it was really the exact same code in all three of those methods, with the exception of the string that we were calling index of contained different values. Other than that, it was the exact same code. So one rule of thumb is don't duplicate your code. All right, so that's the hard part of the assignment, so we can just skip number 4 because that was easy. Hey, all right. So number 4, you were to take in a string called, okay, so we're calling it process expression. This method should take in a string in this format. So the minimal string you'd have is a string containing exactly one number. But you might have an operator followed by another number 0 or more times. Okay? And your job was to process that string and do the math, essentially. Okay? So we're going to do this in pieces. The first thing we're going to do is we are going to capture, we're going to assume our lowest common or our lowest simple case here, which is a string containing just a number. Okay? So that means we need to walk through our string one character at a time until we either hit an operator or we hit the end of the string. Okay, as this is written, there's no white space in here. You could have checked for white space if you really wanted to, but you didn't have to. Okay, so let's go in here. We'll write static. I said it should return that value, right? It should then process this expression and return its result as an integer. So static int, return type is int. We'll call this guy process expression. And this guy's going to take in a string exp for the, it's taking in an expression. All right. And we need to capture the current number. So I'm going to have a string called kernum, and I'm going to start that guy off as the empty string. Our job here is to capture a number. And we're going to do just a small little snippet of this to see how it works. All right, and we're going to draw pictures. So what I'm going to do is I'm going to come out here to, let's see where we stopped here. So in our simple case here, exp sometimes Keynote just needs a little reboot. So we have exp is equal to 1, 2, 3, something like that. All right, so that 1, 2, 3 is actually a collection. Here, I can steal our strings from right here. Is a structure that looks like this. Okay, so this guy's a string named exp. This might be what he holds. That's a guy that looks like this. I'm going to write a loop that's going to go through every element of this string. Okay, and we've done that loop a bunch of times. That's that for loop for int I equals 0, I is less than the name of the string that length, I plus plus. Same loop every single time we want to go take I on a journey from 0 to the length minus 1. So we're going to say for int I is equal to 0, I is less than exp dot length, I plus plus. And we did talk about plus pluses and minus minuses last time, right? Yeah. All right, good. Okay, so this will take I on a voyage through all the indices of exp. Okay, and what we want to do is each time through, what I'm going to do right now is each time through, I'm just going to print the character. Okay, we're going to take this one little step at a time. So I'm going to say system.out.println exp.charat I. Okay, and just so I don't have an error right now, I'm going to change my return type to void since I'm not prepared to return anything right now. Okay, so for right now, this method doesn't return anything. It takes in a string, and all I do is I walk through that string one character at a time and just spit it to the screen. Okay. Nothing too crazy here. So we'll call it with our sample string. Process expression, and we'll pass it the expression 1, 2, 3. All right. Go ahead and run this, and we see a 1, a 2, and a 3 get printed to the screen. Similarly, if we passed it a little bit more complex expression, like 1, 2, 3 plus 4, 5, it'll print out 1, 2, 3, followed by the plus sign, 4, 5. So now we start thinking about how we would solve this problem. I want to walk my string one character at a time until I finally hit an operator or the end of the string. And as I'm hitting these digits, I need to collect them somewhere because I need to do something with them in a few minutes when I need to do math. Okay? So I need to collect the first number somewhere. And we're going to go ahead and do that inside of this string called kernum, which I started off as the empty string. All right, so right now, rather than print these guys out, I'm just going to say kernum is equal to whatever kernum is currently equal to concatenated with exp.charat I. At the very end, I'm going to say system.out.println kernum. So kind of a big waste of time right now. I'm walking through exp, one character at a time, concatenating those characters onto the empty string in kernum. Ultimately, in the end, I have kernum, which should be the exact same contents as exp. Make sense? I'm building that string. So this guy looks like this right now. I start kernum. I start him off equal to nothing. He's the empty string. And then I start adding characters to him. So the very first time through, I take whatever character was at bucket 0 of exp, charat 0, and I copy that into kernum. There's my 1. Loop back around. Now I'm at 1. Is 1 less than 3? It is. So I'm going to copy whatever's at bucket 1, charat 1 in exp, and concatenate it onto the end of kernum. So now kernum has a 2 tacked onto the end. I becomes 2. Loop back around. Is 2 less than 3? It is. So I'll take the character at charat 2 in exp. I'll copy it. Well, I say copy it. I will concatenate it onto the end of kernum, which gives me that. Then 2 becomes 3. Is 3 less than 3? 3 is not less than 3. So we're done. We've looped through the entire exp. And we've built up, in this particular case, an exact copy of exp inside of kernum. So if we were to print out kernum right now, it has 123 in it. So there's our, well, I had the plus 45 in my expression here. I could take the back now to just 123. So I'll pass in 123. 123 comes in as exp. I loop through exp, building up kernum, and then I print out kernum at the end. So the output here is kernum, which is 123. All right. So would you agree that right now I have indeed built up the number that was the first number in our expression? Just so happens that we're dealing with the simplest form of our expression right now. Correct? All right, so now we're going to go back to this guy returning an integer. And rather than print out kernum, I'm going to have this guy return kernum. Now it's going to yell at us. Kernum is of type string. I've advertised that my method will return an int. Make sense? Okay, so we need to turn this guy into an int. And I showed you last class, integer.parseint. Now I have the int version of kernum. And now, since this guy's returning a value rather than us printing one inside, if I want to see the value that comes out of this, like if I run this right now, it's not going to do anything. I am passing 123 in here. It's copying it into kernum, it's converting it to an int, it's returning it, but I'm not doing anything with that return value. All programs begin and end with main, and right now main says call this method and do nothing with what the method does for you. So there will be no output to this program right now. But I can choose to go ahead and print out the result that came out of this though, like this, and now I'll see 123. And we can prove to ourselves that that's in fact a number by me adding 1 to it. Instead of it being 1, 2, 3, 4 or 1, 2, 3, 1, it'll be 1, 2, 3, 4. Oh, I'm sorry. Instead of it being 1, 2, 3, 1, it'll be 1, 2, 4. Because we are adding 1 to it. There's the 1, 2, 4. That proves that this guy was a number that I then added 1 to. So it added 1 to a number, as opposed to concatenating a 1 onto the end of a string. Okay, because if I took the string 123 and I add a 1 to it, the output's going to be the string 1, 2, 3, 1. It treats this as the concatenation operator, not as the addition operator, because there's a string on one of the sides. Understand the difference? Okay. Now, this loop right now goes through the entire string. And in this particular case, we have solved the simple case, have we not? This version of process expression, in fact, does solve the simplest version of process expression for our assignment. That is, process an expression that only has a number in it. This guy does it. No harm, no foul. Done. All right? But many expressions are going to have some of our operators in it. So what I'm going to do is I'm going to create a string called ops. And our operators are plus, minus, times, divide. Is that the only operators? Okay. So these are our 4 different operators. Now, as I'm building up kernum, I need to stop adding stuff to kernum as soon as I hit one of these guys or the end of the string. Okay? Now, before I can do math, I need to know what my current op is. And I'm going to start that guy off as a question mark. Okay, so I'm going to need to keep track of the current operator as well. So if we use this as an example, right here. The very first time through, I'm going to grab the 125. Then I'm going to grab the operator here, which is the plus. Let's see. That looks like it does have white space in it, doesn't it? Okay, then I'll do the version of this with white space. So I'm going to grab this number, and as soon as I hit something that's not a number, that is, as soon as I hit something that is white space or an operator, I know I'm done collecting a number. Make sense? So I'm going to collect that number somewhere. Right now I'm collecting it in kernum. Now I don't do math until I get to I don't do math until I've read in an operator. So if I just finish reading in kernum, let's go back here to this. So I've read in kernum, read in kernum, read in kernum, and this guy says keep going through the entire length of the string. But each time through, I'm going to ask a question. If exp dot char at I, so this is the current character we're looking at, right? I want to know, is that guy, is it true that he is not a digit? Because I only want to collect when it is a digit, right? So I'm going to also give myself a string of digits. That's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. There's all my digits. So I only want to build up kernum if I'm looking at a digit. So that means if digits dot index of this guy, this character, is not equal to -1. Exact same question we asked in the first 3 methods we wrote for the homework. This says if the current character I'm looking at is a number. That's what that says. If it is a number, tack it on to cur num. Make sense? Else, if it's not a number, it's either white space or an operator. Now we've decided we're going to ignore white space, correct? So what I'm going to do is I'm going to say, okay, else if ops dot index of exp dot char at I is not equal to -1. That means I am looking at an operator. And if I'm looking at an operator, what do? Cur op is equal to exp dot char at I. Set the current operator equal to that guy. That make sense? So now I have an operator. And I also have a cur num that I've been building up. Now we need to have somewhere to store our running total, correct? So I'm going to give myself another, this guy's going to be an int, called running total. And we're going to start running total off at 0. All right, that's our starting point. Running total is 0. All right, so I just read in my operator. I know I currently have a number inside of cur num. It's not possible, well, unless somebody gave you bad input. Otherwise, it's not possible for us, if we look at the examples here, if I read in that operator right there, I know for a fact I would have already read in 125 into cur num. If I read in this operator right here, I know for a fact I would have just read in 7 into cur num. So I know cur num already holds a value. Okay? Now, if I hit this operator right here, and cur num holds 125, am I ready to do math? I'm not. Why? Well, yes, I need one more, but why do I need one more? What question can I ask in my method that says I'm not ready to do math yet? Say that again? Okay, so I can compare it to running total. How do I know running total is in its initial state? We need to read in 2 numbers before we can do math, right? Okay, so since this seems to be the way that your logic is going right now, let me do this. Let's call this num1, num2. Read in 2 numbers, right? Okay. We are always going to be building up num2 instead of cur num. So instead of cur num here, we're going to say num2. Instead of cur num here, we're going to say num2. So we're building up num2, and then we finally hit an operator. We just read in an operator if, let's say the operator is a plus sign. So we're looking at something that looks like this. Num2 is this guy, 125, the string 125. I just hit the plus sign. Am I ready to do math? I'm not. Why not? Okay. How do I know I don't have 2 numbers right now? Num1 is empty. Num1 is empty. So I just read in this. I'm going to ask if num1 dot length is equal to 0. That is to say that if num1 has nothing in it, then I know I just read in the first number. And if I just read in the first number, what do? I set num1 equal to num2. And then set num2 equal to the empty string. Okay, so if I just read in the first number, I read it into num2. But now I just realized, oh, by the way, I don't have anything in num1 yet. So I can't do math yet, but I should probably take whatever I just read into num2, put it into num1, and then let's zero out num2 so I can build the next number into that. Make sense? Okay, but I'm not ready to do math. That's if we get into this. So if num1 has nothing in it, I can't do math yet. We're waiting because we got to read in that second number. Okay? Else, what if I am ready to do math? We're going to have to be careful about this operator here, right? This guy right here. What if I am ready to do math? If I am ready to do math, that means what? That means that num1 already has something in it. Num2 already has something in it that we just built up. Correct? I just read in an operator. So if we follow that logic, here's num1. Well, that was num2. I recognized there was nothing in num1, so I copied it over to num1. Then I read in the plus sign. Right? That's what told me I was done with num2. Read in the plus sign, recognized that I didn't have anything in num1, copied the 125 into that. Set cur op equal to the plus sign. Now I read in the 7. I know the math that I'm going to do is 7 plus 125. Correct? Well, let's jump down to the exact same example here, but where there's more operators. So I just read in, so num2 currently holds a 7, num1 currently holds the 125. I just read in the minus sign. But what's the math that I need to do? The plus sign. The previous operator, right? This might be the second operator I've run into. Okay, so I can't immediately overwrite my operator. Does that make sense? I will definitely get a new operator at the end of this else if. But I don't want to overwrite cur op until I've used the current version of cur op to do some math. So if I'm in this else here, that means that I need to take whatever's in num1 and whatever's in num2 and perform the math that cur op tells me to do. Okay? So if I'm in here, I have to do math. So if cur op is equal to plus sign, that means I need to do addition. Right? And what are we going to do? Well, we're going to be adding this to our running total. So we're going to say running total is equal to whatever it currently is equal to plus what? Actually, you know what? I'm going to do this. I want to keep it in strings. This will work fine, but the way I want to do it is this other way. I'm going to set running total equal to, let me do the math first. We know we want to do this. We know we want to say num1 plus num2. That's what we want to accomplish right here, correct? Okay. So how do I add num1 and num2 to each other? These guys are both strings. So I would say integer dot parseint num1 plus integer dot parseint num2. Make sense? That will get the integer version of both of those guys and store the and resolve down to a single integer. And I'm going to store that answer back in num1. Okay? And I think I gave you this hint last time that you can turn a number into a string by concatenating onto the empty string. So we're going to say num1 is equal to the empty string concatenated with this. Whatever this math comes out to. So I'm replacing num1 whatever is currently in num1, I'm replacing it with my running total, which then means I don't need to keep track of a running total because we're going to actually keep it inside of num1. All right, and we'll see how this works when we walk through it. So this is what we're doing if we're doing addition. Subtraction is that. Multiplication is that. Division is that. And good programming practice would probably have been to say else ifs here, but it's not going to be all those, so it would have worked if you just had a bunch of ifs. So if it's a plus sign, otherwise is it a minus sign, otherwise is it a multiplication sign, otherwise is it a divide sign. Otherwise I would say this. Let's say that it was a plus sign. If these were all ifs, I would still ask these questions. Just because it was a plus sign doesn't mean it's not going to be a minus sign. It doesn't mean it's not going to be a multiplication sign. So the else if is better programming practice, but either one's going to give you the same result. We just don't want to waste our time asking extra questions. If it was already a plus sign, we know it's not going to be any of these. So we only want to ask these if this one wasn't true. All right, so this will do math, storing the result back in num1. Regardless of what math we just did, we want to set num2 back equal to the empty string because we're always, always, always building up in num2. Num2 is what we're building our character in, our number in. Okay? Then, regardless of whether this was the first number or we just did some math, I need to capture corrupt. So it's the first time through, I'm replacing the question mark with the operator I just ran into. If it's not the first time through, I'm overwriting the operator that I just applied here. I'm overwriting it with the new operator that I'll be applying later. Okay?
So our statement would be else if division method. It must be else.
No, it's the same. I mean, that's fine. I mean, else is not going to hurt anything if we take that out. But in this case, since we know we're going to be giving it legal input, you would probably say else if this, and then you might have else this is not a legal op, something like that. Okay, so it'll end up functionally being the same thing. We know we're going to give ours the same, give ours correct input. All right, so we do our math here. Zero out num2. Go back and do the whole thing again. Okay? We're going to keep going until we finally hit the end of the string. Now, if we hit the end of the string, there may still be something in, there might be some last minute math to do. And let's see how that works. If I'm over here, if I just read in a 1, 2, 5 and hit the end of the string, do I need to do math? How do I know? What's corrupt? Corrupt is the question mark, right? I started corrupt off as the question mark. So I know if corrupt is the question mark, this was our simple case that we don't have to do any math. Okay? Otherwise, what if I was dealing with this? I read in the 125, then I read in the plus sign, saw that num1 didn't have anything in it, so I copied num2 over to num1, read in that corrupt. Now I'm reading into num2 again, got the 7, I hit the end of the string. I never actually got to do my math because I hit the end of the string before I got into the math part. Make sense? So now I hit the end of the string. How do I know that I still need to do some math? Well, corrupt has something in it. Does that make sense? Corrupt still has something in it. If I'm exiting right here, this is the for loop. For loop ends right here. So that's the else. For loop ends right here. So if I'm down here, if curop is equal to the question mark, I'm done. And what can I do? I can just return integer dot parseint of num1. Okay, but we're going to see that's actually an error right now. Otherwise, if op is not the question mark, I need to do some math, right? If op is still the question mark right here, okay, if it's still the question mark, that means that I'm dealing with our simple case, where it's just an expression with a single number in it, right? Okay. Therefore, curop never got set to anything other than the default, which was a question mark. So if I never read in a operator, what also do I never do? If I never read in an operator, I never copy num2 over to num1. So my only number is actually stored inside of num2. I was going through here, I was building up num2, I was building up num2, I was building up num2. If I ever hit an operator, only an operator, do I say, oh, well, this is the first number, so let's copy it over to num1. Make sense? But if I never hit an operator, if I instead hit the end of the string, and I exit out of this for loop without ever hitting an operator, num2 is the guy that currently holds my string. That makes sense? So this is num2. Otherwise, what do I do? The exact same crap I did right here. Do all the math again, performing the very last curop, right? And then finally, I can return integer.parseint of num1. Make sense? Okay. Now, a couple things we should notice. Well, let's test it first. Let's see if it's doing what it's supposed to be doing. So we're going to call process expression on 123, and this guy should just give us 123, right? Then we're going to call it on, well, I guess I did it on 125. Just trust me, it will work on 125 as well. So now we'll do it on 125 plus 7. There's our 132. Then we'll do it on 125 plus 7 minus 2. There's our 130. Then we'll do it on 125 times 2. $250. And finally, 10 divided by 3. There, 3. Integer division. Right? All right. So that makes sense? Now, as we do this, well, before I go any farther, does anybody, well, let me ask you this. Would it benefit you if I go ahead and trace through this and show you how num1 and num2 is being built up? You want to see how that works rather than taking my word for it? I can't tell from the crowd how much you followed what we just wrote. All right, so what we're going to do is this. I'm going to take our example right here. That's our most complex one out of these. I think we all can agree that whether we're adding something or subtracting something, when we get to that part, that makes sense to us, right? But we need to build up those numbers. So I'm going to start with this string right here. So my expression is that guy. All right. Get rid of these things. So I have a couple of variables. I have crop. And this guy starts off as being the question mark. I have num1. He starts off as the empty string. And I have num2. Who also starts off as the empty string. Okay, so those are our three variables. Okay, these guys are only being used for determining is something an op or is something a digit. Make sense? That's our index of trick. Okay. Now, as we walk through this string, so we have a for loop that's going to go through this string one character at a time. So we're currently there. We're looking at a 1. Is that a digit? It is. What does our code say to do if we're looking at a digit? It says tack it on to num2. Concatenate it onto num2. So I'm looking at a digit, so num2 is going to be equal to whatever it currently is, which is the empty string concatenated with a 1. Then we're going to loop back through. Now we're here. Is that a digit? Yes. What do we do when we see a digit? Tack it onto num2. So num2 is whatever it used to be, concatenated with a 2. Loop back around. Now we're there. Is that a digit? It is. So what do we do with digits? We tack it onto num2. Now we're right here. Is that a digit? No. Okay. What does the next thing say? It says, is that an op? So we just failed this if statement, right? So now we need to go to the else if. Okay, well, is it an op? Is that guy an op? Nope. So if it's not an if, or I'm sorry, it's not a digit, it's not an op, that's the end of our loop. We loop back up. So we did nothing. We ignored it. We ignored the white space. Hey, look, it wasn't a digit, it wasn't an op, I want nothing to do with you. Just kept on cooking. Make sense? All right. So now we're here. Is that a digit? No. Is that an op? Yes, it's an op. Now we get into our second, this else if. So that was true. Now we ask the question, is num1's length equal to 0? Here's num1. Very lonely right here. There's nothing in there. So that must mean we just collected our first number. And what do we do when num1's length is 0? We set num1 equal to num2. And then we zero out num2. So I set num1 to be the same thing as num2. And then I set num2 equal to the empty string. That's all I do. All right? And that's if I was looking at an op. So I just got into this part of the if, which means I will not get into the else here. So the very last thing I do is I set curop equal to the operator I just read in, which in this case was the plus sign. So curop is no longer the question mark, now it's the plus sign. All right, spin back up. Now I'm right here. Is that a digit? Is that an op? Okay. Now I'm right here. Is that a digit? Yes. What do I do with digits? Tack it onto num2. Spin back up. Is that a digit? Is that an op? What do I do? Keep going. Is this a digit? Is that an op? Yes, it's an op. It's an op. So we're in the else. We ask the first part of our else here. Is num1's length 0? It's not. Num1 has crap in it now. Right? Num1's length is not 0. So we go to the else. What does the else say? Else says, do some math. It wants us to look at the current value of curop. The current value of our curop is right here. It's a plus sign. We just hit the minus sign, but we haven't overwritten curop with it yet. Curop currently is a plus sign. So since it's a plus sign, what do? We get into this first if here that says, set num1 equal to the empty string concatenated with the integer version of num1, the current version of num1, plus the integer version of num2. Okay? And then we'll overwrite num1 with the string version of that by concatenating this integer onto the empty string. We get the string version of that integer. All right? So that's what we do if it was a plus sign. Fair enough. So we've done that. So that's 125 plus 7 is 132. Store the result back in num1. So now num1 is 132. Make sense? All right. So now we fall past all these because they're all else ifs, and we got into this first one. And the very last thing we do when we finish this else, the else associated with, hey, we're looking at an op, is we set curop equal to the one we just read in, which was this guy, a minus sign. So now we could overwrite curop with that minus sign because we just used the plus sign. We did the math based on it. All right. So then we spin back up. Actually, before we spin back up, oh, here, good. I'm like, why does this work? Outside of all these ifs and elses here, notice we zero out num2. After we finish doing our math, before we loop back around, we set num2 equal to the empty string. So num1 holds our current answer. Num2 is now the empty string. We spin back up. Next character is this guy. Is that a digit? Is that an op? Nope. Now we're at this guy. Is that a digit? Yes. What do we do with digits? Concatenate it onto num2. Okay. Spin back up. Now we're off the end of the string. So our for loop ends. Okay, because I is no longer less than exp.length. So now we are past the for loop. We're right here. Okay? Now we have a question to ask. Is curop currently equal to the question mark? No. It's got a real operator in it. We got math to do. Right? So since we actually have some math to do, we're going to go through and we're going to do our math code. This else. If it's a plus, do this. Ours happens to be a minus. So curop is a minus. So we're going to set num1 equal to the string version of num1 minus num2. 132 minus 2 is 130. Stored as a string inside of num1. So we've done our math now. And finally, we will return the integer version of num1. So integer.parseint of that guy, which will give us 130 as an int. That make sense? Now, just to quickly show you the question mark version of this, let's say that this is our current code. Go through our for loop. We're right there. Is that a digit? Yes. What do we do to digits? Tack it on to num2. Now we're right here. Is that a digit?
Yes.
Yep. What do we do with digits? Num2. Now we're right there. Is that a digit? Yes. What do we do with digits? Num2. Now we're off the end of the string. Notice we never had the opportunity to copy num2 into num1. Okay? So we just finished our loop. So we're sitting right here. Now we ask the question, is curop equal to the question mark?
Yeah.
It is, which means that we want to return the integer version of whatever's in num2. Right there. That make sense? All right. Easy? Okay. When you see it now, we can see that it's made up of a whole bunch of easy parts. The complex thing for us as beginning programmers is, well, kind of a statement I say pretty often is all hard programs are made up of a bunch of easy parts. If you were to look at the source code of Windows 8, you would see a whole bunch of crap like we're seeing here. Just instead of 60 lines of it, you'd see millions of lines of it. Okay? All hard programs are made up of a bunch of easy parts. It's our job. Now, first of all, you probably noticed that we only had to look at the code a couple of times there, right? When we were going through it over here. When I said we hit a 1, is 1 a digit? Yes. What do we do with digits? Put it in a num2. We didn't have to go look at the code. That was a recipe, right? We were following that recipe. Sure, this spaghetti crap over here said to do all that, but wasn't it a lot easier once you saw what our code was doing for us to solve it as a person? It's like, oh, easy. It's a digit, tack it on to num2. It's a digit, tack it on to num2. It's a digit, tack it on to num2. That's what we do with digits. Well, is it an operator? Nope. It's not a digit, not an operator. What do we do with it? Nothing. Move on with life. So once we kind of got the pattern down, we saw how this solves this problem with a pattern, then it was easy for us to understand it. That doesn't mean that it's going to be simple for you to write all this. If you look at this one line at a time, this is no big deal. Defining a variable of type string, filling it with some crap. Another one, filling it with some crap. Another one, another one, another one. Oh, here's our simple loop. That's the loop that goes through strings. Written that several times, no big deal. Okay. Oh, here's a little question mark. Well, this is the crap we practiced in the previous 3 methods. Right? No big deal there. What's this one? Oh, same crap again from the previous 3 methods. This guy just asks, is it a digit? This guy just asks, is it an operator? All right, fair enough. All right, well, now here's another if statement. Well, this is just asking about the length of a string. Is that a big deal? Well, maybe not. We get to the else. What's this guy do? Well, he just asks if a char is equal to another char. Each step here is very simple code. But when you put it all together, then it becomes intimidating, right? Okay, now that we've seen this, one thing I want us to kind of do is if you're looking through this code, and I mentioned this earlier today, we want to minimize the amount of code that we duplicate. Okay, when we looked at the first 3 methods that we wrote today, in the end, we wrote another method that was the generalistic part of those 3, the repeating part of those 3. So we could just call that whenever we need it. So right off the bat, we might say, you know what? This mathy crap looks a whole lot like this mathy crap. Make sense? So maybe we write a mathy crap method. And whenever we need to do mathy crap, we call the mathy crap method. All right? So we come down here. We're going to say static int mathy crap. Mathy crap's going to take in 2 strings, string num1, string num2. And it's going to return the integer. Actually, it also needs to take in a char op, the operator we want to do. Okay? And what we're going to do, I'm just going to steal this code up here. And instead of calling this call this curop. All right, so it's going to take in curop, so now all these things work. All right, so this says if curop, if this guy is a plus sign, add num1 and num2. At the very end, what are we going to do? We're going to return integer.parseint num1. Actually, we probably want to have it return a string just to keep up with what we are doing. So we'll have it return a string, which is just num1. All right. So now we know we have a method called mathycrap that we can pass a string to, another string, and an operator, and it will return for us the string representation of that operator applied to those two strings. Make sense? So what I'm going to do here is I'm going to do the little minimize button. Now that looks less scary. And I'm going to come up here, and whenever we do mathycrap, I'm going to take all this stuff out. I'm going to say driver dot mathycrap, pass it num1, num2, and curop. And we'll store the answer inside of num1. Same thing up here. We have all this mathycrap. Store the answer in num1. That makes sense? Something else to notice here. Notice that in this if and in this else, we're setting num2 equal to the empty string, both places. So we probably, let's take it outside of the if and else and only do it once. Because this stuff happens regardless of which of these we got into. Make sense? All right. Now, another thing you might say, well, I have this method I wrote earlier that's called what? Print inset. And print inset really is pretty close to something else. We might say, well, let me do this. Static Boolean is digit. This guy's going to take a character as a parameter. He's going to return a true if the character I pass it is a digit and false otherwise. So I'm going to return the digits dot index of C not equal to -1. So here's a string. I'm calling his index of method, passing it the char. And if that char is found somewhere in here, this would not be equal to -1. It would be equal to like a 0 or 1 or 2 or 3, wherever that guy actually lives in that string. So that means this would be true. That's a Boolean expression. What's a Boolean expression? Any expression that boils down to a single value of true or false. This is a string. This is a method. This boils down to a number. But now I'm applying a Boolean logical operator to it, comparing it to another number, so this whole thing boils down to a true or false. And I'm returning that true or false. So that's is digit. Is op. Same thing. So I have is digit and I have is op. Minimize those down. So now what I could do is I could take out these two lines. I don't need those variables anymore. And instead of this random crap, I could say driver dot is digit And this one is up. So now this is starting to read a little bit more like we were going through it in our recipe, right? Is the current character a digit? No. Is the current character an op? Make sense? The code has not changed. We've just encapsulated this data inside of a method called isDigit that happens to do the isDigit stuff. We encapsulated the same logic we had before inside of this method called isOp. And it has all the isOp stuff. Now we just call those. Okay? And then all the mathy crap we put inside of a method. So whenever we need to do mathy crap, we're done. So now process expression is a lot shorter than it used to be, because we wrote methods for some of the things that might be reusable. Make sense? Remember, a method is a reusable chunk of code. The best example of that for us here is this mathy crap stuff. This is not difficult code, but this is a chunk of code that takes up space. And we know we might, in our example, we had to call this twice. So let's write it once and call it twice instead of writing it twice. Make sense? All right. So that is the homework. And we should see that this guy still works. All right, questions about any of that? Piece of cake? I have one here, don't I? Yes, piece of cake. I can validate. All right. So, some things you should have gotten out of that assignment. 1, 2, and 3, the first three methods. If you figured out the index of trick, which I heavily hinted towards, those three should have been very easy. You shouldn't have found 1, 2, and 3, relatively speaking. 1, 2, and 3 should have been far easier than the fourth method, right? Now, after looking at the fourth method, we see why we need to draw pictures, why we need to solve the problem as a human first, and then we can go and write the solution in code. As we walk back through our code, we see, oh, this makes sense, this makes sense, this makes sense. But if you just stare at a wall of code and you don't have experience doing this stuff, it becomes very overwhelming. You're looking at it like, okay, well, I know I need to solve this whole problem, but all I see is a wall of code. We need to go and solve this problem. Write the code for that. Then we need to solve this problem. Write the code for that. Then we need to solve this problem. Write the code for that. Then all of a sudden we can solve this problem followed by this problem followed by this problem, and oh, it sort of kind of works. If you roll back to, whatever, half hour ago, 40 minutes ago, when we first started looking at process expression, I started off with a very small version of the method. Let's just read in a string and walk through it one character at a time. Let's make sure that part's working. Okay? Now I'm accessing each individual character. What are some things I can do with those? Well, I need to capture them somewhere. Well, so let's do some concatenation. We concatenated each character onto another string, proving that we were able to copy the contents of one string into another. In the big scheme of things, it's not solving our final problem, but it was a piece of the bigger picture, piece of the puzzle, right? Okay, taking little tiny baby steps and coming out here and drawing pictures and figuring out your recipe before you just dive into the code will be very, very helpful. And even then, when you go to dive into the code, don't try to solve the entire thing at once. Solve one little piece of it. Okay, so you're going to decide this problem is solved by doing this, followed by this, followed by this. Well, the first time you write code, only solve part A and make sure that your solution to part A of that works. Then solve part B. Make sure just part B works. Then make sure A and B work together. Then solve part C. Make sure just part C works. Then you can make sure they're all working together. Make sense? Okay. You have to start with little baby steps. The example I always use, and it works out better in the grad classes than it does in the undergrad classes, because typically the grad students are a bit older. How many of you have ever seen the movie What About Bob? One person? Bill Murray? You haven't seen What About Bob?
I don't know. I can't remember.
Richard Dreyfuss is in it. So What About Bob? Yeah, What About Bob is, so you got Bill Murray, you know, Ghostbuster, right? And he's got some anxiety issues. Okay, so he's going to a psychiatrist, a shrink. And Richard Dreyfuss plays the shrink. And Bill Murray, he's, you know, huh?
He writes a book.
Yeah, the guy writes, the shrink writes the book. And the name of the book is called Baby Steps. That's where I make this connection. But in any case, though, the Bill Murray character, he's afraid to go outside, basically. You know, he's afraid of everything, touching doorknobs, okay? So he goes to the shrink, and the shrink gives him his, you know, his best-selling book, and, you know, here, give me your money for this book, but read this book, Bob. You know, well, I'm going on vacation, but you read this book. The book was about taking little baby steps. So, you know, if he's leaving the office to go home, you don't just leave the office to go home. You're leaving the office to make it to the elevator. And from the elevator, you're making it to the lobby. From the lobby, you're making it to the parking lot, so on and so forth. So the premise of the book was baby steps. Well, then his shrink goes away on vacation, and Bob's so happy that this is working for him, he goes and stalks his shrink, and hilarity goes from there.
Even marries his daughter.
Huh?
Even marries his daughter.
Yeah, marries the daughter. Yeah, they didn't go over that well for the shrink initially, but it is a funny movie. You should watch it. Most Bill Murray movies are pretty funny. I just watched, what did I see last night? My wife and I watched The Grand Budapest Hotel. It was a strange movie. I thought it was pretty good. Bill Murray's got a kind of a, not a cameo, but a cameo plus role, and he's in it probably for about 10 minutes, something like that.
Is that kind of a current movie?
Yeah, it just won a bunch of awards. Just won a bunch of awards. It's on HBO now. Yeah, it was from 2014, and then I mean, I think it won like a ton of awards at the Oscars or whatever. You know, it did well. It was good, but it was one of those movies at the end you're like, that was strange, but I think I liked it. It's one of those. So I don't know. I guess I'd recommend it. My wife slept through most of it. In the end, my wife goes, I thought you said Bill Murray was in this. So she missed that 15 minutes. Guess what are you going to do? All right. So let's look at something more difficult. Because this was easy, right? Very easy. Baby steps. Okay. And actually, that's a real... The reason I give you, I suspect you will find this week's homework easier, even though this week's homework is harder. I give this assignment early on. I usually give a harder version of this than I gave you. As almost a torment. I'm doing it to purposely torment you. Most students, when you tell them that you need to write things out, take those baby steps, things like that, they don't listen. Oh, I got a programming assignment, so what do? I plop down in front of Eclipse. We're going to program. And you just start typing crap, and then you're testing, you're hitting play, testing, hitting play, until just magically the world comes into alignment, and you think it works, right? And then what you do is you start going online, you're copying crap from Google, and you're pasting it in there, and then you got to make that work. Like, okay, well, I stole this from 7 different sources, and I need to get these to work together. I don't even know what this is doing. Some of you know this feeling, right? Okay. So I make this assignment easy enough in concept, but we can certainly see by looking through it, it's complex enough that there's so much stuff going on that if you don't think through it, this is a nightmare to do this homework, right? Okay, so how many of you found the part number 4 to be a nightmare? Mission accomplished. Okay, drawing pictures will help a lot. Okay, but we have to. Nobody listens, right? The first time around, you have to experience it yourself. Okay, so yeah, that was the point of that. But now I'll show you how it was actually intended to be even harder. Typically, I do not teach you the integer.parseInt method prior to doing this assignment, which means that if you have the string what if I told you I wanted you to write a method called string to int that takes a string as a parameter and converts that string into its integer equivalent? You do not have access to integer.parseInt. Essentially, you are writing integer.parseInt. So this is always an interesting problem to look at, because when all of us look at this number, we know exactly what 123 is. Right? In fact, we're so good at numbers, base 10 numbers specifically, that we've forgotten how they work. So, I'm giving you the string 123. How would you turn that into the number 123? Forget about programming for a second. Okay? I've thrown down in front of you three index cards in a certain order. One of them has a 1 on it, one of them has a 2 on it, one of them has a 3 on it. And I'm telling you those are currently characters. We need to, utilizing those 3 index cards with letters written on it, with characters written on it, we need to turn that into the number that is represented by those index cards. How are we going to do that?
3 times 1, 2 times 10.
Okay, tell me about this. So you said 3 times 1, 2 times 10. Why'd you say 1 and 10? Huh? This is decimal. Okay, so decimal means base 10, right? Okay, so if this is a, well, let's just look at the base 10 number 123. I'm going to put some spacing here. That's weird. Why did it... Guess it doesn't really matter. Just put it underneath here. So you said this is the ones place. And you said this is the tens place? What place is this? Hundredths place. All right. So another way of writing this, this is 10 to the 0th place. Ten to the 1. 10 to the 2. So 10 to the 0th power is a 1. 10 to the first power is a 10. 10 to the second power is 100. 10 to the third power is 1,000. Make sense? So this is 1 times 3 is 3, plus 2 times 10 is 23, plus 1 times 100 is 123. Make sense? All right. So I need to go to my string, and I need to walk my string from here to the beginning and sum up the answer. So in this example, it is 3 times 1. Put these in parentheses. Plus 2 times 10 plus 1 times 100. Add all that up, we get 123. Okay, couple of issues here. If I go to this element of my string, that's not the number 3. That's the char 3. Well, how do I get the number 3 out of the char 3? That is to say, again, baby steps. I want to write the method static int char to int. A method that takes a character as a parameter and returns its integer equivalent. So if I pass it in the character 3, it would spit out the number 3. The character 6 would be the number 6. How would you do that? So we're solving a whole different problem now. Move this stuff up here. So if I gave you the character 3, I want you to tell me how can we turn that into the number 3.
If x equals 3, then x returns 3.
Okay. So if C is equivalent to 3, return 3 like that? Okay, what about the rest of them? So a bunch of if statements? So start this off at 0. Return 0. Else if 1. Return 1. Else if 2, 3, 4, 5, 6, 7, 8, 9. Ah, like the way you think? Well, I guess I'd say almost like the way you think. You're on a reasonable track. All right. And then maybe have our else. -1 or something like that. Kind of like the index of method. If you pass me a char that I can't convert into a number, I'm just going to give you a -1 for no good reason. Right now we're just going to assume that we're given real values. Will that work? Okay. Oh my gosh, look at all that crap. How can we do that in one line? The exact same logic in one line of code. And this isn't a goal to minimize our lines of code. If you're solving a problem, the solution we just had there, perfectly reasonable. I mean, it's not creative, but it's functional. Nothing wrong with that. But we want to practice some of the stuff we've learned in here. So I want to write in one line of code the equivalent to what we just had. And I don't want it just this giant if. We're just going to keep all that logic on one line. Okay? I want it to make sense to be on one line. Well, you're allowed to do it in one line, so you can use the is digit if you'd like. What does is digit do for us? Here's our is digit. He just tells us whether or not a particular character is a number or not. That's all that guy does. All right, so is digit's not going to do us very much good in this situation. It's a string method. Here, I'll give you a hint here. It's one of the methods represented on this screen. One line of code. Do we use index of for this? How can we use index of to solve this problem? Okay, so if I have all the numbers, say this again?
Is not equal to -1.
Well, let's write our numbers down first. So we have the string like that, right? That's all the characters. And I say dot index of. What's this going to give us? What will that boil down to? The index. If I pass this the char 0, that is, if I pass it that guy, what will this boil down to? The number 0. Because the character 0 is located at index 0 in that string. The character 1 is located at index 1 in this string. That make sense? And what if I had passed in a question mark? Return a -1. It's not found. So the exact same logic we just had can be represented just like that. Search this string for this character and tell me where you found it. I will find 0 at position 0, 1 at position 1, 6 at position 6, 9 at position 9, question mark at position -1. Not there. That makes sense? So that will allow us to convert a char into an int. That could be helpful. All right, what else? Now we got to go back to the string to int problem.
How about if we convert the char to the int? Well, the number 1 won't give us number 1 in this case. And then we just subtract the difference and get the number 1 again.
Okay, well, let's start here first. Here's my string, right? I have the string 123. Okay. How many characters are in this string?
3.
How many characters in that string? Generically. How many characters are generically in that string? S dot length. There's S dot length number of characters in the string. There happens to be 3 in this one. But I'm going to have to look at S dot length number of chars. And for each of those chars, I'm going to have to convert it to its number equivalent. And I'm going to have to multiply it by the current place that it's in. And we liked starting at the ones place, then going to the tens place, then going to the hundreds place, then going to the thousands place, so on and so forth, right? So I need to do something that's going to take a number on a voyage between 1, then 10, then 100, then 1,000. How do I do that? Let's start with just that piece. I want to start off. I'm going to make this void just for a second. Show well, let's see. Show the first 10 powers of 10. That's what I want this guy to do. Show the first 10 powers of 10. Oh, what's the first power of 10? 10 to the 0 is 1. What's the second? 10. What's the third? 100. Okay? So I want to show 10 of them. So how do I do something 10 times? For loop. For loops are, we're doing repetition, so we're going to use a loop. And we're going to use a for loop because it's a counting type problem. So I'm going to say for int I is equal to 0, I is less than 10, I plus plus. That'll do something 10 times. Okay, so whatever I do in here will happen 10 times. Fair enough? What am I going to do in there? I want to show all the powers of 10. Well, I want to show the first 10 powers of 10. Well, what's the very first power of 10? So int pow, start off at 1. So you're going to print that out, system.out.println, pow. Now how do I transform pow into the second power of 10? Multiply it by 10. Pow is equal to pow times 10. Now it's 100. How do I get it to the third power of 10? Times 10 again. Times 10 again. Times 10 again. So this is constantly multiplying pow by 10. 10 to the 0, 10 to the 1, 10 to the 2, 10 to the 3, 10 to the 4, 10 to the 5, all the way up to 10 to the 9. So print out each one. We'll go ahead and call this method driver.string to int, and it's not even using our parameter right now. We're just passing it in because it says we have to. It's just going to go through and show us the powers of 10, the first 10 powers of 10. Fair enough? All right, so we solved one little tiny problem. We solved the problem of taking 1 to 10 to 100. Now I need the problem of, this is our string, 1, 2, 3. So I needed to go from bucket 2 to bucket 1 to bucket 0. I really need to go through that string backwards. The loops we've written up to this point always started at the beginning of the string and went to the end of the string. But now I want to go from the end of the string to the beginning of the string. Make sense? All right, so let's solve that problem. We'll just pretend like we have this in our notes somewhere, so we get rid of that for a second. I promise I'll remember it. Now we want to walk S backwards, showing each char. So I'm going to write a loop, right? Do I know how many characters are in S? S.length number of characters. So it's a counting problem. So it's a for loop. For int I is equal to, what's the last legal position? S.length minus 1. So we'll start at S.length minus 1. We're going to keep going as long as I is greater than or equal to, what's the first legal position? 0. And what are we going to do to I each time? Subtract 1 from it. We'll start in a situation where we have 3 characters. We'll start at 2, go to 1, go to 0, and we do want to deal with 0. That's why we say greater than or equal to 0. So that's a legal position. And then we get to -1 and we'll fail. How do I get the current character, the character in our string at position I? S.char@. I. So now I'm passing it blah. So it should print out halb. Blah backwards. So we walked our string from the end to the beginning. Okay. So now if I do the same thing, it should say 3, 2, 1, right? Now, what if I want to print out the integer version of each of those characters? Because right now, we happen to know that when it's printing it out right here, it's printing out a char. That guy's a char. I really need the int version of that char. Do I have a tool that will convert a char to an int? I do. So I'm going to take this character and I'm going to pass it char to int. So I'm going to pass this char in as a parameter to my char to int method, which will magically convert that char to its integer equivalent. Now, when we run this, visually it'll look the same. It'll look like 3, 2, 1. But we will know that that's actually the number 3 and the number 2 and the number 1, as opposed to the char 3, the char 2, the char 1. Make sense? Okay, so seemingly no different, but we know there is one. All right. Now, let's throw our POW back in there. POW start off at 1, right? So now we're printing out the numeric version of each of our characters, and we're also printing out our current power of 10. So now we've kind of merged those two little mini solutions together. We're not using them together yet, but we've merged them together to show us that we're getting those two values, right? So now we should get the number 3 and POW is 1. The number 2 and POW is 10. The number 1 and POW is 100. 3, 1, 2, 10, 1, 100. That make sense? What do I want to do with this 3 and the 1? Multiply them together. Add it onto the next two multiplied together. Add it onto the next two multiplied together. So I need to have a sum. And each time through here, I want to say sum is equal to whatever sum is currently equal to plus this number times POW. And then we'll make POW be 1 bigger than it used to be. In the end, I can return sum, which now I can change our string to int back to return an int. So now this guy takes a string as a parameter, and it does make the assumption that this string is a legal string. We'll deal with that after we take a break. We'll talk about exceptions. But right now it assumes that we're passing it numbers. If we pass it Bob and tell it to convert that to an int, we're going to have some issues. Okay? We're going to have a lot of negative ones getting returned by our char to int thing. So in any case, we can pass it a string. It's going to walk that string backwards, taking each integer version of each char, multiplying by the current POW, and each time through, POW will become 10 times larger than it used to be. And then we're going to return the sum. Print this out, and we'll see that it looks like 123. Now that could be the string 123, but we know that's the number 123. And we can prove that to ourselves by taking the result of this and adding 5 to it. And we will get 128 instead of 1235. That makes sense? So we wrote our own little method for converting a string to an int without having to rely on the index of, or I'm sorry, the integer.parseint method. So even if you were not given integer.parseint, you could write your own. Now, this was a lot easier to understand than the big long piece of code we wrote today, right? But does this look easier than you suspected it was going to be when you first thought about the problem? I need to convert a string to an int. When you first think about, I need to convert a string to an int, human beings don't immediately jump to, how do ints work? We're thinking about one animal and another animal, and how do we make this guy become this guy? We broke it down into 3 or 4 little tiny steps and then solved each of those problems. This problem was actually a harder problem to solve mathematically than the previous problem. At the very least, it was as hard. A lot less code, so it's less intimidating, and we know a little something about the background. We just forgot what we knew about it. Actually, surprisingly, several of you remembered how numbers work. I mean, that's something we take for granted. How often have you ever thought about, oh, well, that's in the hundredths place, or that's in the thousandths place? That's not something that just comes up, right? Not since like 2nd grade, 3rd grade or something. We don't think about those things anymore. But they're there, and we just take it for granted. So this caused us to have to jump back to that kind of idea. Now, what would happen if I did say, convert Bob to an int and then add 5 to it? What's the output here going to be? Well, when we try to convert B to an int, we're going to get a -1. So -1 times 10. I'm sorry, -1 times 1 is -1. Then we're going to get, when we try to convert an O to an integer, we're going to get a -1. So -1 times 10 is -10. So now we're at -11, right? All right. -106. Because our method right here returns a -1. When we passed B in here, it said, oh, well, where's B in this little set of integer, or this set of characters here? That's not there, so we returned a -1. Probably not what we want. Because I'll tell you, if we do a system.out.println integer.parseint Bob, try to add 5 to it, we're going to get a less friendly response. Okay, we get a number format exception saying, hey, Bob is not a number. Right? Well, so we'd like to be able to do stuff like that. First thing is, how do we determine if this guy's a number? So we wrote our isDigit down here, but isDigit takes it a char, not a string. So what would you say if I wanted you to write a method static Boolean is number that took a string as a parameter? We want this guy to return true if S is a number, return false if S is not a number. So we want this guy to detect numbers.
Make it portable.
Okay.
Check all the all the.
Okay.
And then see if they're all numbers or not.
Okay, so you're saying that in order for a string representation of something to be a number, every single digit, every single character in it must be a digit. Okay? So a bunch of ands. For int I, doesn't it matter if we go from the end or from the beginning? We just have to check all of them, right? For I equals 0, I is less than how many characters are in S?
String -1.
S dot length. I plus plus. By saying I is less than, that'll go to S dot length minus 1. So this will take I on a journey through all the characters, all the indices of S. At each place, we want to find out, is the current guy a digit? Well, how do I ask that question?
Convert from char to integer.
Can I use my isDigit method? If driver dot isDigit, the method we wrote, and this guy takes a character, what character should I pass it? S dot char at I. Okay, so this currently asks the question, if S dot char at I is a digit. What do we do if it is a digit? If just one character is a digit, the whole thing must be a number? If I'm walking through all the characters in a potential number, characters in a string, rather than looking to see if it is a number, we might look for things that disqualify it from being a number. So if I bump into, so rather than saying they all have to be digits, we might say that none of them can be non-digits. So if I run into any character in that string that is false when I pass it to isDigit, that means this guy's not a number, because it's got something in there that was not numeric. So driver.isDigit, we can say equal false, if we like that version of it. That's actually redundant. Probably the correct way of running it would be not that. If this boils down to true, not that is false. If this boils down to false, not that is true. So this says if it's true that this character is not a digit, what are we going to do? I ran into one character in this string. It might have been the first one, might have been one in the middle. That's not a digit. Return false. That means that this whole number is not a number. So we'll return a false. Oh, else return true? Oh, I'm glad you walked into that trap. Why won't that work? Now we're rolling the dice. We get to the very first character in our string. We say, hey, are you a digit? If he's not, we'll return false. But if he is, we're not going to check the rest. We're not going to check the rest of them. I'm sure since the very first character was a digit, rest of them must be. That's what we're doing right now. We either return true or we return false the very first time through the loop.
Get the else out of the folder.
So really, and this is another pattern, and then we'll take a break here in a minute. I want to return true outside the loop. This is a pattern that I like to call the minefield. This is our minefield. If we survive this loop without ever returning false, and I get dumped out after the loop is done, meaning I've checked all the characters, if I'm still alive, that must mean I never ran into a situation where I was not looking at a number. Therefore, the whole thing must be a number. Make sense? I survived the loop. So this statement checks to see if something is a number. All right, so let's take about 15 minutes or so. When we come back, I want to talk about exceptions, and we'll write it in terms of this is number thing, kind of like the integer.parseint. All right, so let me stop this.